All right, so we're making great progress. We now have our rider view controller up and running, and the rider can request an Uber, and that is then stored on Pass. Next, of course, is to add the driver view controller, and this is a little bit more complicated, but let me show you how it's going to work. So I've already created a Rob driver user, so I'm going to log in with him, and now you can see we've got a number of requests. So these are ones that I've created, and they're being searched for nearby on Pass, and you can see that they're correctly ordered as well, with the closest ones at the top. And these are being updated as the driver location potentially updates as well. So if we click on the first one, we jump over to a map which shows the location of that rider and gives the rider the option to accept the request. Even more impressively, when we click accept request, then that jumps over to Apple Maps and allows the user to navigate directly to that username. So Rob1, and indeed get full directions, so they'll be there in 4 minutes. So that's quite a lot to ask, but I'm sure you're up to the challenge. The main new thing, of course, is working out how to get those directions in Apple Maps. But that's something that's pretty open to Googling, and if you Google something sensible, you should find fairly straightforward code to do that. Another couple of notes is it's worth, when you get the user to accept a request, to mark that request as accepted, and then it shouldn't display on the list of open requests anymore. Okay, so that's the plan. Best of luck. Hope it goes well. Okay, here we go then. I'm going to start, of course, in main storyboard, and this time I'm going to bring in a navigation controller, because we're going to want a table view and also a link to another view controller where we're going to show the rider's location for that particular request. So here we go. So I've changed the layout here to reflect that there are two possible ways that we could go when the user logs in. Either it's a driver or a rider. So let's add in a new segue to our navigation controller. And this will be called show driver view controller. There we go. And then we can go back over to view controller, and now we can fill in the gap that we had before, that if they're a driver, then we want to show the driver view controller. There we go. And we'll do that also down here, and finally in view did appear as well. You might want to set that up as a method, because we have got a fair chunk of code 3 times there, which is a little bit unnecessary, but I'll leave that up to you. Okay, so now we want to set up our driver view controller here, which is going to be a table view controller. So let's create a new class for it. Cocoa Touch class, and we want a subclass of UI table view controller, and I'm going to call this the driver view controller. There we go. So let's now set everything up as we're used to. So we'll have one section and my usual 4 demo rows. We'll set up the cell text label, text to be equal to test, and we'll set the reuse identifier to cell. And then back over to main storyboard. In fact, it's probably easier to do it here. So in the table view root view controller, we'll set the class to be the driver view controller. And in the table view cell, we'll set the identifier to be cell. Okay, so that should be enough to just view the table view controller and the test content. Of course, we're going to need to log out and then log back in again as a new user who is a driver. Here we go. So let's log out. Now we get an interesting crash there. That's something we need to deal with. And the reason is because we're still updating the location even after we've logged the user out. So there's an easy fix to that, is when we log the user out, which we do here, then, in fact, we'll do it just before, just in case. We'll take our location manager and we'll stop updating location. There we go. So that's important to avoid the attempted location update when the user is not logged in, which then causes that crash. Okay, so let's create a new user called Rob Driver. And this guy is going to be a driver. So let's sign him up. And there we go. So we've now redirected to the new root view controller with our test content. All right. So first of all, we don't really want that to be called root view controller. So let's update the title of this view controller. And I'll call it request list. And while we're here as well, let's add a bar button item for logout. Remember, we do that down here. There we go. We'll call it logout. We'll set the title to logout. And we'll add a segue back to the initial view controller. And as we did before, we'll look in the prepare for segue method to see if the segue identifier is equal to, and then we'd better give this one a segue identifier. I'll call it driver logout segue. Copy that over. Then we're actually going to do two things. So the first one is to take the user and log them out, for which we'll need pass. And the second is we'll remove the navigation bar at the top, which we do using self.navigationcontroller.navigationbar.is hidden and set that equal to true. And that will stop the navigation bar continuing to appear over the initial login screen, which is not what we want. Okay, worth a quick test, I think, to make sure that everything is working as desired. So initially, we should then jump past the login screen because we're already logged in as a driver. And then when we log out, we should go straight back to the view controller without a navigation bar. There we go. Super. So let's just log Rob Driver back in. That should take us back to our request list. Wonderful. Oh, let's quickly fix this message. So rider requests was defined but never used. Yes, okay. So that was where we were just checking to see if a request was active or not. Okay, so the first thing that we're going to do is populate our table with the active requests. So at the moment, if we just check, we have one active request, which should be quite near to our current user, which makes life easier. We're going to need, of course, the driver's location to be able to work out how close they are to the users that have made the rider requests. So let's set that up. We'll need CL location manager delegate. And we'll need a location manager variable, which will be a CL location manager. So then over in view.did.load, we'll set up our location manager. So as we're now familiar, we set the delegate to the view controller or the self. We set the desired accuracy to KCL location accuracy best. We set the request when in use authorization, and then we start updating location. There we go. And then when we update the location, we look for did update locations. And here we write our code to update our table. So let's get our location from the manager variable again. So manager dot location dot coordinate. And then once we've got the location, we need to run a query. So let's set up our query as a PF query on the class name rider request. So that should get this data here. And then we just want one where key. And this is going to be a nearby or near geopoint request. So we want where the location is near the user's or this user's location, so the driver's location. And we're going to create that as a PF geopoint using a latitude and longitude. And that's going to be location.latitude and location.longitude. And this does two things for us. It gets the rider requests near our current user, and it also orders them by how close they are to our user, which is exactly the behavior that we want. I'm also going to limit the query to 10 users. If we've got hundreds and hundreds of requests, then we don't want them all displaying. I'm sure they'll be able to find one out of the nearest 10 that they want to go for. Okay, then we take our query and we find objects in the background with a block, as we're now hopefully very comfortable with. Then let's take our objects. Actually, I'll call these rider requests. And then we want to loop through them if we can. So rider requests in rider requests. And then we want to update the information about this request to a central array. So let's have an array called request usernames. And this is going to be an initially empty array of strings. And we'll append this new username to that array. So this is going to be rider request username. So remember, we stored the username here in the rider request PF object, and we'll likely need to cast that as a string. So we'll just do a quick if let username equals rider request username as string. We're pretty confident that that will work, but always good to do a check. There we go. So that should update the request usernames array with all the usernames that have an active request. So before we go any further, let's update our table data to use request usernames to get the data. So request usernames.count to get the number of rows in the table, and then for now we'll just display the username. So request usernames and index path dot row. Okay, let's give that a try. So that should return just the one username of Rob Rider, because that's the only request that we've got so far. Let's have a look. So it's getting the data, and we're not seeing anything there. My guess is because the two are now too far apart. So I'm going to cheat slightly and print the user's location, print the driver's location, and then we'll set the user's location close to that, so we don't have to worry about the user going off on their cycle ride or the driver moving too far away from the user. While we're here as well, I'll set the location to a fixed location, so the Apple headquarters. Okay, I'm going to stop that. There we go. So now I'll put our user location to be pretty much equal to our driver location. And just before we run that, we should update the table when we finish looping through the rider requests. So we just use self.tableview.reload data. There we go. So now with any luck, we should see the single request populated in our table. And there we go. I've got a slight bug there. Of course, it appends it every time it loads it. So let's quickly stop that and make sure that we remove everything in the request usernames array before we load it. And just a note there, if you don't get any results, it might be worth just checking your user location and making sure that your driver hasn't moved outside of the range of your rider. And what I actually did while I was testing was take the debug and change the location to a fixed location. And that just saves then the danger of someone moving out of range and you wondering why you don't have any results in your table anymore. Okay. So I'm also going to quickly get a few more requests going so that we can see more than just Rob Rider. There we go, we'll stop that for now. And in fact, while we're there, we should make this so that when the user logs out, it stops the location as well. So location manager, stop updating location. We may well have received a crash. Oh no, we haven't. That's good. Okay, so I'm going to create a couple of new rider users and let's give them some slightly different locations. There we go. So we'll call an Uber there and just check. There we go. So we've got our new Uber location for Rob1. And let's create another new user. So another rider, Rob2. Interestingly, it's coming up as a result for Rob2 in rider requests, which is definitely not the case. So let's quickly go over and fix whatever's causing that. So here, I think we should check for objects not being nil and also objects count being greater than 0. So it looks like we get an empty object back if there's no results. So objects is not nil, but it is empty. So let's just do another check of that. And here, yes, we can do that a little bit neater. Actually, we'll just use let objects equals objects to unwrap it, and then we don't need the exclamation mark anymore. As long as we spell objects correctly, of course. Okay, so we'll just try that again. And this time we shouldn't get the error that we're being asked to cancel an Uber before we've even created one. Here we go, that's better. So let's call an Uber for Rob2. And we'll do one more. So we'll create a new rider and call an Uber for them. And there we go. So let's have a quick refresh. And there you can see we've got all four requests now. Great. So let's log out and log back in as Rob Driver. And now you can see those requests ordered by location near to our user. Brilliant. It will be good to know exactly how far away these are though. And fortunately, we can do that quite easily with Parse. So we'll do it by extracting the user location when we get the request information. And we'll need another array. I'll call it request locations. And you could store these as PFGeo points or any kind of location type that you like. I'll go for CL location coordinate 2D because that allows me to use a range of Swift methods for finding distances between locations. So let's take the request locations and append and we're going to want a CL location coordinate 2D. And we're going to create that from a latitude and longitude. So the latitude will be the rider request location dot latitude, and the longitude will be rider request location longitude. And just as with request usernames, we're going to want to clear all of the request locations before we update them all again to avoid duplicates. And then we'll go over to our self-aware index path, and this is where we'll work out what the distance is. So one thing that we'll need to be able to get is the user location, which at the moment we can only access inside the didUpdate locations method. So let's add it here. So var user location, and this is going to be a CL location coordinate 2D. And as before, we'll initially set it to a latitude and longitude of 0. And then we'll update it here to set user location equal to location. Okay, so we can now use user location wherever we like, and we're going to get it just here. So now what we're trying to do is find the distance between user location and the request location, which is request locations index path dot row. Now both of those are CL location coordinate 2Ds, so we just quickly need to convert them to CL locations to be able to find the distance between them. So let's have a user, or just to make it clear, we'll have a driver CL location, and this is going to be a CL location with a latitude and longitude. So this is user location dot latitude and user location dot longitude. And we want to do the same for rider CL location, and this is going to be a CL location based on, again, a latitude and a longitude. So latitude will be request locations index path dot row dot latitude, and similarly for the longitude, request locations index path dot row dot longitude. And then we can just work out the distance between them using distance equals driver CL location dot distance from, and then that's from rider CL location. And that will give the distance in meters. So I'm going to divide that by 1,000 to get the distance in kilometers. So now we'll show the username, but we'll also show a hyphen and then distance kilometers away. So that should also display now the distance between each individual user and the driver. Let's check it out. There we go. So you can see we've got those distances. The only slight issue there is I think we've got probably more accuracy than we need. I don't think we need to know that level of accuracy, but we can see, importantly, that they're all ordered correctly, which is great. So let's make it 2 decimal places. I think that's probably enough. And to round to 2 decimal places, we take, in fact, let's take a new variable, call it rounded distance. And we're going to take the distance multiplied by 100, and then we're going to round that to the nearest whole number, and then we're going to divide that by 100, and that will give us our rounded distance. So it's a slightly roundabout way of rounding, but we can't in Swift just go immediately to, say, 2 decimal places or 4 significant figures. We have to go to the nearest whole number, and then so if we want to go to 2 decimal places, we multiply by 100 and then divide by 100. If you wanted 3 decimal places, you'll multiply by 1,000 and divide by 1,000. So there we go. Now we can see all our distances, and actually they're updating live, which is nice. So Rob1 is now slightly closer than Rob Ryder. Great. Okay, so now we have our request list. Our final thing then for this video is to allow the user to tap on one of these, view the user's location precisely on a map, and then choose to accept that user's request. Okay, so to do that, we'll need a new view controller. So we'll bring in just a standard view controller. It's going to be quite similar to the one that we had for the rider. We just need a map view and again a button to accept the request. Here we go. And then we'll set up a segue to this view controller. I'll call it show rider location. And while we're here, we'll create a new class for that view controller. And this is going to be a subclass of UI view controller. And we'll call it rider location view controller. And we'll create it right there in the app. And before we forget, let's link that up to our new view controller. There we go. And while we're over in main storyboard, let's add our MapKit view. So make that nice and large. And we'll have a button which initially will say accept request. Okay, then over in the view controller, that is the rider location view controller, we'll add an outlet for our map. And an action for accept request. And while we're here, an outlet for accept request button. Make sure you name it something different. Okay. Then let's import paths before I forget, and import MapKit as well. And we'll add an MK map view delegate so that we can control the map. Okay, so what we want to happen is when the user taps on one of the rows, it jumps over to that new view controller and shows the location of that particular user. And I'm actually going to do this differently to how we've done it before, just to show you that there is another way. So we're going to go back to main storyboard, and I'm actually going to delete this segue by pressing backspace. And then I'm going to set up a segue instead from the cell itself. So from the cell itself to the new view controller. And then each cell will automatically jump to the new view controller, and we can use the prepare for segue method to do any code that we need to before that jump takes place. So now I'll call this one show rider location view controller. Copy that. And then over in driver view controller, we can now put our code into the prepare for segue method, which is here. So else, then we'll look for if segue dot identifier is equal to show rider location view controller. Then for now, we'll just print. And you might be wondering, how are we going to know which cell was tapped on? Because normally we do that within the cell for row at index path method. Well, we can get that from table view to access our table view, and then index path for selected row. And that will give you the row that has just been tapped. And we'll make that an optional because we're not certain at this point that a row has been tapped, although we are certain because the only way that this segue can happen is from a row being tapped. So let's just check and make sure that that behaves as expected, i.e. we can now click on a table row and that will jump through to the new view controller. Okay, it definitely does. Difficult to find the actual code that we want though. I think we'll just have to trust that there's a number in there somewhere. At least we'll find out soon enough. So what we want to do is pass the location of the rider request to our new view controller. And we do that by first setting up the variables themselves. So I'm going to have a request location variable, and this is going to be a CL location coordinate 2D from a latitude of 0 and a longitude of 0 initially. And then we're going to go to our driver view controller and set the variable in the new view controller to have that value. And we can do that by creating our destination view controller as a variable. And we can get that from the segue. And we get the destination view controller. And we do need to cast that to the correct type. So this is going to be rider location view controller. And if we're able to do that, then we'll set destination dot request location to be equal to our request locations, and then table view dot index path for selected row dot row. And let's just see, we're likely to need to force unwrap that, which I'm a bit nervous about. So just to be absolutely sure, let's create a row, which is going to be equal to tableview.indexPath for selected row dot row, and then we'll use request locations row. There we go. Okay, so now we're going to jump over to the new view controller, and the new view controller will be able to access the location in the request location object. So for now, all I'm going to do is in the viewDidLoad method, I'm going to print location and then print request location. And I'm doing that first print so that I can find it inside all of the other stuff that's going on in the console. So this is just to check that we're passing on the location correctly. So let's have a look. I'm looking for location and colon. There it is. And you can see we've got that new location. Brilliant. So now let's take that location and display it on the map. So it's easy enough. We can actually start with a region for our map immediately. So this is going to be MK coordinate region with a center of request location and a span of MK coordinate span. And we'll stick to our fairly close zoom of 0.01, 0.01. Then we'll set the maps region to have this region animated true, and we'll add a pin to the map as well. So let annotation equal to MK point annotation. We'll set the coordinates to our request location. We'll set the title, and here it would be good to show the username. We're going to need the username anyway if the user wants to accept the request. So let's add a variable request username, and initially we'll make that an empty string, but then over in driver view controller we'll update it. So we'll take destination.request username and set that equal to request usernames row. Then back over to our new view controller. So now we can use request username as the annotation title, and then we'll add that to the map. Okay, so let's take a look. We should now, once we get over our errors, where are we? Okay, I've created it as a let, which was foolish. Should of course be a var. All right. So now when we click on any of the users in the table, it should show us a map of the location of that user and have a nice pin in the middle that shows the precise user's location. And there we go. Wonderful. Let's try another one. Brilliant. Okay, so that's all looking really good. All that remains then is to write the code for accept request. So let's do that down here in the accept request method. So first off, we're going to need to find the request on pass. So we'll create a query, which will be a PF query with a class name of rider request. And again, we only need one where key, and that's going to be where the username is equal to our request username. Very simple. Then we can find objects in the background with our block, with some objects and hopefully not an error message. So I'm going to ignore the error message and go straight for the objects. So these should be rider requests. And if they are, we're going to loop through them. And as we saw previously, we don't need to cast them this time. So for rider request in, whoops, got ahead of myself a little. So that should be rider requests equals objects. And then we're doing for rider request in rider requests. So now we need a way of specifying that this request has been accepted. So I'm going to take my rider request and set a variable called driver responded equal to, and we'll set that to the current user's username. So pf user current username, and then we'll save that in the background. Okay, and while we're here, we should then go back to the driver view controller and change our query to have an extra where key. And we should change this to only update usernames and locations if not only we can get the username, but also we need the rider request driver responded field to be empty. So as well as checking that the username exists, we're also going to check that rider request driver responded is equal to nil. Because if it's not, that means a driver has already responded to it, so we shouldn't display it on the list of available rides to drivers. Okay, so now back over to rider location view controller. So now we've updated the information about the rider request. So now our final thing for this video is to show the driver directions to the rider's location. And that we can do by first getting the address details using reverse geocoding and then launching Apple Maps to provide the directions for us. So let's see how we do that. First off, we create a request CL location because we need a variable of type CL location to do a reverse geocode on it. So this is going to be a CL location from a latitude and longitude, and this is going to be request location dot latitude and request location dot longitude. Then, and you may or may not remember this, we take our core location geocoder and we want to reverse geocode a location. And that location is request CL location. And we'll double click that. We'll hopefully get an array of place marks. We might get an error. And of course, we're inside a closure here. So we need to add self to get the request location variable. Okay, here we go. So first off, let's check to see if place marks can be unwrapped. And if it can, we'll check to see if it's got some objects in it. And now we're going to take our place mark 0 and convert it to an MK place mark, which is just a different type of place mark which we can use to get directions to in Apple Maps. So it's an MK place mark created from a place mark, and that place mark is going to be place mark 0. Remember, place mark 0 is the first item returned, usually the only one, but if there's more than one, then they'll be very close together anyway, so we can use this first one. And yes, of course, that should be place marks 0. So that's our MK place mark. We then create what's known as a map item from this MK place mark using MK map item from our MK place mark with a lowercase m. And the only extra bit of information we need to specify is the name. And I'm going to give that the request username name. So self.request username. And then we're almost there. And then we're nearly there. We're about to open Apple Maps, but we just need to create some launch options before we launch Apple Maps. And we only need one, and that is the MK launch options mode key. If I can find it. There it is. And we want MK launch options directions mode driving down at the bottom. There it is. So this says that we want to navigate to this location by car. And then finally, we take our map item and we open it in Maps with the launch options being launch options. There we go. So quite a roundabout method, but a very powerful thing to be able to do. We can now offer directions to anyone right from our app. So let's check it out. Let's choose the closest request, and then we'll click accept request. And you can see we've now jumped over. There we go. So from my location, and you can see that's where it used the name. And yes, we'll allow Maps to use the location. So that's the name of the new location. And then route. There we go. So it's given a nice 8-minute route there to pick up our user. Brilliant. So we're pretty much there. The rider can now navigate to the user's location. And of course, he can still see and select all of the available riders and choose which one he wants to accept. So all that remains then is for the user to be told that the driver is on his way, and it'd be great to tell the user where the driver is and how long he's going to be as well. And we'll do all of that in the next and final video in this section.